Some floats are unique because they have even more sensors. We've got a pH sensor and a dissolved oxygen sensor, as well as a nitrate sensor. And then down here at the bottoms, there is also a chlorophyll and backscattering sensor that pulses different bandwidths of light to collect that data. And then we deploy the floats. They will go into the ocean and they will go down to 2,000 meters deep, which is about 1.25 miles, and then park themselves. Basically, they have a buoyancy engine in them so they can go up and down in the water column. Slowly, over the course of about 7 hours, they come back up to the surface and all of their sensors are collecting data as they move their way through the water column. And then at the surface, they beam all that data back to us on land and they make GIA every 10 days. In the meantime, they stay at 1,000 meters depth, but then that's where they direct for those 10 days. Now let's see the working of the chatbot responses to the user's question. The user's prompt, asking for the temperature of the Pacific Ocean, is sent from the React UI to our Fast API server. There, a LangChain agent performs a full RAG pipeline, retrieving context, generating SQL, and querying the database. The final data and AI-generated summary are then packaged and rendered by the front end. On the right, you see the raw data retrieved from the database, visualized as an interactive chart. And on the left, our AI provides a clear conversational summary of the findings, generated by the LLM. In the next screen, let's see what the system architecture looks like. This diagram shows the complete architecture of our FloatChat application. It's a modern cloud-native system built in 3 distinct layers: the front end where the user interacts, our cloud backend, which is the brain, and the data layer, which holds the memory. A user's journey starts in the front end, a React application hosted on Vercel. When a user asks a question, it sends a request to our cloud backend on render. This backend is a fast API server that orchestrates the entire process. It immediately hands the request to our LangChain AI orchestrator. The orchestrator first searches our internal vector store, the AI's fast memory, to get context, like which specific float the user is asking about. With this context, it then calls an external LLM API, our AI brain, to generate a precise SQL query. The orchestrator executes this SQL query against our main PostgreSQL database, which is hosted on Supabase and holds all the factual measurement data. Once the data is retrieved, the orchestrator sends it back to the LLM one last time to translate the raw numbers into a friendly, human-readable summary. The final result, the summary, the chart data, and the chart type, is packaged into a single JSON response. This entire package is sent back to the React front end, which then displays the conversational answer and the beautiful interactive visualization to the user. From a complex question to a clear insight in seconds. Thank you.